All right, without further ado, let's look at the question number J, or question letter J, I guess. Here is another epicyclic gear for you. This time I drew it by hand, so it's a bit more vivid. Colors are more vivid than the previous one. But okay, the problem is almost the same problem. Let's suppose we know the knowns. Well, last time I used a black pen, so black color. So knowns would be, we know the angular velocity of the first gear and the second gear, or the sun gear. What we want to find is the angular velocity of the seventh gear, but just so we don't have the confusion we had on the earlier problem, let us label the rigid bodies that we see on this diagram first. So this is the second rigid body. Let's suppose this is the first rigid body. This is the third rigid body. This is the fourth rigid body, right? Because this rigid body is exactly the same rigid body as 3. So, and similarly, this one here is the fifth rigid body. Okay. So what we need to find is the angular velocity of the fifth rigid body. So I'm going to call it omega 5 because the angular velocity of the fifth rigid body is just omega 5 in the k direction, as long as I define my axis to be I that goes up the page, and k that goes horizontal in the page. Okay? Okay, really good. Okay. So great. This is sigma naught. And let's have a point that's fixed on the Earth. Again, some point O that's fixed in the frame sigma naught. Okay? Okay, let's work through this problem. What are our constraints, right? The constraints are that the velocities of P1 and P2, actually let me call them P2 and P3, not P1 and P2. These are okay. The pitch point between gears 2 and 3 is called point P, and P2 is the point that coincides with P, that's on gear 2, and P3 is the point that coincides with P, that's on gear 3, right? So the constraint is that the velocity of point P2 must be equal to the velocity of P3, right? Similarly, the velocity of point P4 must be equal to velocity of point P5 in 0, right? P4 and P5 are the pitch points on gear 4 and 5 respectively, okay? And velocity of P6 must be equal to the velocity of P7, okay? Okay. So let's compute the velocity of P2 in 0, right? For that, I take up the position vector that goes from O to P2 and take its derivative. Simple stuff. So let me take the derivative of the position vector that goes from O to P2. This is going to be what? It's going to be angular velocity of the second gear, which is omega 2k, cross R2, and this vector is in direction I and has radius R2, right? Which means R2 omega 2 in the j direction. Great. What's the velocity of P3 in 0? Well, to do that, I first need to go to this point, right? Let's call that point A, and let's call this point B for future. To find the velocity of point P3, I first need to go to point A and then come back over here, right? So it's going to be looking like what? So that vector that goes from O to A is fixed in the first rigid body, or the carrier, and the vector that goes from A to P3 is fixed on the third rigid body, or the third gear, right? So this is going to look like omega 1 k cross r2 plus r3 in the I direction. Why? Because this distance is r2 plus r3. Yeah? Plus angular velocity of 3 in 0, which is omega 3k cross, what is this distance? That's r3, but the direction is negative I, right? So it's going to be minus r3 in the I direction. And computing this, we're going to get r2, r3, omega 1, plus or not plus minus r3, omega 3, all in the j direction. And the equality we need is the equality of these two things. So we have r2 omega 2 equals r2 plus r3 omega 1 minus r3 omega 3. Yeah, that's our first equality. Great. So this one here, and this came from equating these two things. Velocity of P2 in 0 to velocity of P3 in 0. Great. Now, let's look at velocity of, let's equate velocity of P4 to velocity of P5 in 0. So velocity of P4 in 0 is what? How do I compute that? Again, I need to go here and then there, right? And take the derivative of that sum of those two vectors, which is going to give me the derivative of RO to P4, pretty much. But I'm going to do it in two distinct steps. The first one is our derivative of RO to A plus derivative of RA to P4. Now, ROA, we just did that, was what? R2 plus R3 times omega 1 in the j direction, plus the position vector that goes from A to P4 is what? R4 in the I direction. But that vector is fixed on which frame? Actually, the third rigid body, right? Or the third frame. So this is going to be omega 3k cross R4 in the I direction. So the result is R2 plus R3 omega 1 plus R4 times omega 3 all in the j direction. Yep. Okay, so the velocity of P5 in 0 will be computed by taking the derivative of the position vector that goes from O to P5. Again, that's going to be dissected into two vectors that goes first from O to B plus B to P5, right? So the derivative of O to the position vector that goes from O to B, what is that? Well, that's fixed in the first frame, first of all. So using differentiation in two frames formula, I find omega 1k cross. What is this distance? That distance, let me tell you, that distance is can be written in two ways. One way is R2 plus what? R3 plus R4 plus R5, either that, or maybe more succinctly, it's R7 minus R6, right? So let me do that. R7 minus R6 in the I direction. Yeah, plus derivative of R, the position vector from B to P5. That position vector is fixed on the fourth rigid body, so it's going to be, again, repeating, the fourth rigid body is the rigid body that carries gears 5 and 6, right? So that's going to be omega 4 in the k direction cross, what is B to P5 is what we're thinking about. So this thing is, distance is R5 and the direction is minus I. So it's going to be minus R5 in the I direction. Yeah. So the result is R7 minus R6 times omega 1 minus R5 times omega 4 all in the j direction. And the equality will be between these two expressions, right? So let me write that. R2 plus R3 times omega 1 plus R4 omega 3 is going to be equal to R7 minus R6 times omega 1. Oh, by the way, let me write this as the alternative expression, which was R2 plus R3 plus R4 plus R5 actually times omega 1 minus R5 times omega 4. Yeah? It's going to become clear why I wrote it this way, because there is an omega 1 term and omega 1 term on both sides. So it's going to simplify when I write it this way, right? What's it going to simplify to? Well, pretty much I can see that there's an R2 and R3 term here, and I can cancel them with these terms, right? So what I'm going to get left with is pretty much R4 plus R5 times omega 1 equals R4 omega 3 plus R5 omega 4, right? So that's the equality that I need to retain. I'm going to delete all the remaining stuff, move this guy all the way up here, and then remember that this came from this equation right there. Actually, I just need to copy it, paste. There we go. Finally, I have to match the velocity of P6 and P7 in the zeroth frame. What's the velocity of P6 in 0? To go do that, I'm going to have to take the derivative of the vector that goes from O to all the way to P6. But to do that, I'm first going to go to B and then from B to P6. Okay? So that's going to be derivative in 0 of RO to P6, which is going to be done in 2 steps. Derivative in 0 of vector that goes from O to B plus from B to P6, right? Remember, we did the derivative of this in the a few minutes ago, and that was what? R7 minus R6 times omega 1 plus where is this vector? Where does this vector? Where is this vector fixed to? That vector is fixed to the rigid body number 4, right? So I'm going to take that derivative in the 4th frame, use differentiation in 2 frames formula, and I'm going to get omega 4k cross the vector that goes this way has magnitude R6, right? So it's going to be R6 in the I direction, which is going to result in this says J as direction, R7 minus R6 times omega 1 plus R6 times omega 4, all in the J direction. Yeah. And finally, velocity of P7 in 0 is going to be computed by taking a position vector that goes from all the way to P7, right? And that's going to have so that vector is fixed on the 5th rigid body. So it's going to be using differentiation in 2 frames formula, omega 5k cross R7 in the I direction, which is going to give you R7 omega 5 in the J direction. So the equality is between these two things, 2 expressions. So if I just write that equality down, I'm going to get R7 minus R6 omega 1 plus R6 omega 4 equals R7 omega 5. Yeah? Great. So let me retain that one and erase the rest. Great. Oops. I didn't want to do that. I just want to erase this. Put this here. Extend the separator. Copy this bit right there. Okay, those are our equations, right? Again, the aim was to find omega 5 given omega 1 and omega 2. So this time I guess I'm going to do the elimination just for giggles and kicks. So let me take this equation and solve for, from that, solve for R4 times omega 3, okay? So what do I have? Let me name, label them so I can refer them back. So from star, I'm getting the following. R3 times omega 3 equals R2 plus R3 times omega 1 minus omega R2 omega 2. Okay, from here I can compute that R4 times omega 3 is going to be R4 divided by R3 times R2 plus R3 omega 1 minus R2 omega 2. Okay, why did I compute this? Well, I see that exactly over here in the second equation, that's why. So I take that, plug it all the way over here. So now working on the second equation, but plugging in what I found for R4 times omega 3, I am getting R4 plus R5 omega 1 minus this whole thing, minus R4 divided by R3 times R2 plus R3 omega 1 minus R2 times omega 2 equals R5 times omega 4, right? I see here R6 times omega 4, so I need to compute that in terms of omega 1 and omega 2. To do that, let me first simplify the second equation. From here I am getting the following. So R4 plus R5 minus, let me see here, minus, what do I have as minus? 1 plus R2 divided by R3 times R4 times that's the next thing I have as minus. Everything is in parentheses. Plus R2 R4 divided by R3 times omega 2 equals R5 omega 4. So if I want to find R6 times omega 4 from here, I need to multiply everything on the left by R6 by R5. So R6 by R5 times everything over here, R4 plus R5 minus 1 plus R2 minus R2 divided by R3 times R4 omega 1 plus R2 R4 R6 divided by R3 R5 times omega 2. Okay, and now I have an expression for R6 times omega 4. I'm going to go ahead and plug that in the third equation. So that's going to give me what? R7 minus R6 times omega 1 plus this whole thing, right? Which is gonna be like Mike. That's not gonna be like Mike, so it's gonna be 1 plus R4 divided by R5 times R6 minus 1 plus R2 divided by R3 times actually R6 over R5, all of them times omega 1 plus R2 R4 R6 divided by R3 R5 times omega 2 equals R7 times omega 5, right? So I need to massage this a little bit again, just so that it looks a bit better. So we have, what do we have? Omega 1. So I need to take that into parentheses, and then I have to divide everything through by R7, right? So it's going to look like minus 1 minus R6 divided by R7. I just divided this thing by R7, and plus 1 plus R4 divided by R5 times R6 by R7 minus 1 plus R2 divided by R3 times R6 divided by R5 R7, everything times omega 1 plus R2 R4 R6 divided by R3 R5 R7 times omega 2 equals omega 5. Okay, so not sure if I can simplify this any further. Perhaps I could, but I'm just gonna keep it this way. I guess it's more pain than it is worth. So here is our answer. There you go. Sorry about that abrupt finish, but that's what it came down to at the end. Okay. All right. Hope have fun studying these things. It's hopefully fun for you as well. Goodbye.